Hello and welcome to the VMAX video tutorial series. In this video we are going to go ahead and head to the Visualization Studio and begin interacting with some of the exhibits that we have in VMAX. Now in the previous video, if you've watched them, we learned how to walk around and we learned how to modify your avatar to your liking. If you haven't done that yet, go ahead and take a look at those because you'll need to know how to move around before we're really able to go on to the next part of these tutorials. Okay, so the next part is we're going to go to this Visualization Studio. So just click it, and now you're used to a door opening, but it's going to be a little different this time. You click it, and it's going to teleport you. Now the place we've teleported is this is the Visualization Studio, and it's a giant room where all kinds of things are going to be happening. This is sort of like the central meeting area when you have multiple students all coming together in one place. They're mostly all going to meet here. Okay, and you have some things to read. Now, remember, you move around. You can either do that using the W, A, S, D keys, or you can go ahead and use these little arrow keys. And we're going to head over to this exhibit right here. Right, I'm going to hold down Alt, or if you are on a Mac, you would hold down Apple, and we're going to zoom in, and we see what we have is the transit method. Now, this is one of the methods that you use to observe exoplanets in hopes of finding them. And we'll see how this works by basically interacting with it by sitting on this chair. Now, when I sit in the chair, all I did, by the way, I just clicked on the chair and it sat me there. That's all I had to do. All right. Now, when I sit on the chair, I look around, and the reason why it's changed my view, it's gone into a mode called mouse look. And mouse look lets you look with the mouse. You no longer see yourself, and now I've controlled where your eye level is. And that's important for the transit method because that lets us see what is happening there. If you take a look, you see a little planet. Unfortunately, it has missed the sun in its orbit. What we want to see for the transit method is that planet moving in front of it. And students will be able to control that in various ways. In this particular case, we're moving the distance from the star, which is one of the variables that they may encounter, and also the inclination, which is that angle that it's making with the star. And as you can see, as I changed it just by clicking on it, now that planet will actually perform a transit. It's actually moving in front of the star. So students will sit down and they'll use this to get a general feel. On the left-hand panel, you have sample data, and this data basically shows you the kinds of data that NASA really will get, and that's going to be fluctuations in the brightness of the star. And if you see this drop, this very rhythmic drop, you know that at a very fixed period of time, the brightness of the star is dropping, and that's one of those clues that there might be an exoplanet. Okay, so I just hit the escape key, and what you'll have here, if you click on stand, that gets you out of the chair. So that is the transit. Now we have another exhibit that we can go take a look at. It's over here. And this is what we call the Wobble method. And I'll go ahead and sit in that chair as well. And once again, we're in the mouse look. What the Wobble method demonstrates is the fact that when a star is orbiting a sun somewhere, a star, it's not just the orbit. It's not just the planet that's orbiting the star, but the star is technically orbiting the planet. They're actually tugging on each other. Now, the star is much, much more massive than the planet, of course, but still, the effect on the star is not zero. It will have a wobble. It will, just as the star will sweep your path from left to right as it orbits the star will do the same, only very slightly. And what this method shows you is how this little planet orbiting the star will cause the star to actually wobble. As you look at it, it will go ahead and move from left to right of your visual field. And once again, you can interact with these exhibits by clicking on them. In this particular case, we're changing the distance from the star and also the planet size. We can go from big and small. And that's how that works. Once again, you'll have real NASA data that will demonstrate the concepts, and the Wobble method. Of course, this first set of exhibits are intended to give you an exaggerated view in order to help the student understand the concepts. So it's not intended to be to scale. It's just to let you know here's an exaggerated display so that you understand, you're able to internalize the concepts, so that when we move on to the real data, you understand what's going on. Once again, I'm hitting escape, and I'm going to click on stand, and we're going to head on over to our next exhibit. And this exhibit is the direct imaging. And the idea behind the direct imaging is that you might actually be able to see the planet. Just as you might try and see something that's very tiny and dim in front of or very near a floodlight or something extremely bright, what you might do is you put your hand in front of your eyes and cover up the bright thing so that you're better able to see the little dim thing. And it's the same idea with the direct imaging method. What you do is you have an occulting disk of some sort, and that's represented by this black spot. And the students are able to maneuver that around. Now, I'm just going to move it over here, and you can see when we're looking directly at the star in front of us, it's very bright, and it's fairly difficult to see anything. But the idea is, as we take this occulting disk, and I'm going to start to cover up that star, yes, you might see it if you look right over there. Now, because we've hidden most of the star using this occulting disk, we can actually see that there's a planet there, which was very difficult to do. It's like this little black spot now. And that's how direct imaging works. And we have a little bit of sample data. You can see right here. We're going to see more of this later, but by covering up the incredibly bright star, we're able to see the planet that goes around it, and that this is real data. So real data compared to the theoretic kind of exaggerated data. Okay, and now we're going to stand up, and I think I'm going to break now. So this has been the three main exhibits that demonstrate the methods that we use to discover stars or discover exoplanets. In the next video, we're going to explore the visualization studio just a little bit more, so you see the other facets of it, and then we'll probably move on to the labs after that. So I'll see you there.